Thank you, Susan. Good evening, all, and welcome to IIRSM Qatar branch section. So this year, this is our seventh section, which we have been going through online. And hopefully, in coming days, slowly we will be planning to start our face-to-face section as well. So welcome to all members and guests for today's section. So myself, Deepu Ravi Kumar, Chair of IIRSM Qatar branch. So today we have the topic safety precautions for electrical installation in the workplace, which will be presented by Mr. Varmik Soni, who is currently working as a trainer inspector with Vibrant. He has over 4 years of experience in electrical engineering. He also done his electrical engineering from NIT India, and he worked with many projects in India and here in Qatar as well in electrical department. And also he has gone through NEBOSH courses in process safety and IGC courses. So I know Valmik from quite for a few months when he joined with Vibrant, and I'm so happy that he volunteered himself for today's section because he has sound knowledge in electricity. He has background on that. So I'm so happy to welcome Valmik for today's section. So Valmik, you can start.
Oh, okay, thank you for the introduction, sir. Welcome everyone for the webinar for safety precautions for electrical installations in the workplace. I guess everyone, whoever is, whichever site, whichever location that you're working at, there is probably no chance where there are no electrical installations, right? And whenever working around high voltage electrical installations, you always need to be careful. You always need to be a bit safe, right? So we'll be talking about those things, different types of high voltage electrical installations that you might find in your workplace, and the safety precautions that you need to take around them, right? So let's start with the webinar. The agenda for today's webinar, we'll start with the introduction to electricity. I think everyone has a basic idea for about electricity, what electricity is, but just as a start of the session, we'll just cover some basic things about electricity. Then we'll move on to the different types of high voltage installations that you can find in your workplace, right? There are different types of things. There are transformers, there are circuit breakers, there are current transformers, potential transformers, relays, right? So we'll talk about all of those high voltage installations. The hazards whenever working around high voltage, right? There can be different types of accidents, different types of hazards that can be there, and major disasters can happen if proper care is not taken, proper safety is not followed. So we'll talk about the different hazards, the different accidents that can happen around any kind of high voltage installations. And then once you have identified the hazards, we'll move on to the safety precautions, the control measures that need to be taken around all of those electrical installations individually, right? And lastly, in case there is an accident, in case there is an emergency that happens, the electrical accidents, the electrical emergencies need to be treated differently. There's a separate procedure for that. So we'll talk about the emergency procedure in case of an accident, in case of an emergency as well. And lastly, it will be open to you guys for any questions, anything that you want to ask on the topic. All right, always feel free to ask any questions about the topic. Okay, so let's move on to the first topic, that is the introduction to electricity. Electricity, as you all know, that's the basic movement of current in any circuit. Right? Electricity is defined as the movement of electrons, that is the movement of the flow of current in any conductor. Right? The few basic related terms that you need to be aware about in electricity. Current, basic thing, that's the movement of electrical charge or electrical electrons in a conductor. That's the flow of electrons. Resistance is the opposition to the flow of current, right? Higher the resistance, lesser the current. Lesser the resistance, higher the current. All right. Voltage is the opposite of resistance, is the force that is required for a current to flow through a conductor, right? So higher the voltage, higher the potential for higher rate of current to flow through a conductor. That's why it's usually when a person gets a shock, that is because of current that it happens. But usually when we refer to shock, we refer to as the voltage, right? It's a 440 volt shock or 11 kV shock, right? That is because of the voltage, because of the voltage rating. Higher the voltage, higher the current that can flow through the conductor. That's why it's always the voltage that is referred to, but it's the current that usually affects the human body. All right. And then there is conductors and insulators. Conductors are the substances or the materials that the current can flow through, right? The conductors have very less resistance, so there are chances of very high current flowing through those conductors. And the insulators are opposite. They are the substances such as dry wood, rubber, glass, right? The insulators that have very high resistance and hence very low current might be passing through those substances, those materials. And there is also grounding, which is very important when it comes to electrical installations. Any electrical installations in the workplace need to be grounded, they need to be earthed so that any leakage current passes through the ground and minimizes the risk of any electrocution that might happen while working around high voltage installations. All right. Then different types of electrical installations that you can find in the workplace, right? The first and foremost thing that you can find is the power distribution transformers, the huge transformers in your workplace, in the substation that you can find, right? Those are very high voltage transformers, at least 11 kV transformers, right? Since there is 11,000 voltage going through it, that voltage is stepped down for the industrial use, right? So if those transformers are not taken proper care of, there can be huge disasters that can happen. All right, there are high voltage cables connecting the distribution transformers, the power transformers, to the electrical panels inside your electrical room. All right, so there are different types of high voltage cables as well. They have their own hazards, their own accidents that can happen around them. Particularly for high voltage cables, they can be overhead or underground. When it comes particularly to Qatar, when there is electricity that is transferred from one location to another, maybe from a city to another, that is through overhead cables, and the all of the connections inside that city is all underground connections, right? So whenever it comes to overhead cables, overhead connections, most of the overhead cables are uninsulated, they're bare, right? Just to increase the efficiency of the power transfer. So whenever working around overhead lines, or whenever if there is an excavation work going on, there can be underground cables. So they pose their own hazards, their own dangers, right? So we'll be talking about that as well. Then there can be current transformers and potential transformers. So basically, current transformers and potential transformers make it easy for a relay or a meter on your electrical panel to measure the current or the voltage, right? When there is a current passing through an electrical room, or when there is a potential or a voltage passing through the electrical room, it is very high in rating. And we have relays that are maybe electromechanical relays or electronic relays which work on very low voltages, right? Like for example, you can take your phone for example, that has very low voltage. If those high rating of current or voltage passes through an electronic system, that's gonna damage the electronic system severely, so that needs to be stepped down to be passed on to your relay or to the circuit breaker. So that's what the current transformers and potential transformers do, right? Stepping down maybe thousands of amperes of current to maybe 1 ampere or 5 ampere, right? That's the range, that's the ratio for a current transformer or a potential transformer. So in case there is any hazards happening around that, there can be that rating of high current that might be released. And around current transformers and potential transformers, there are high risk of arc flashes or even arc blasts that can happen. So we'll be talking about those things as well, how the current transformers work and the hazards related to it. Then circuit breakers. I think most of you are familiar with circuit breakers. Uh, there can be huge amount of circuit breakers, like you can see here on the pictures on the right side, the rightmost two pictures. The top one is the vacuum circuit breaker panel, and the bottom one is the air circuit breaker panel. There can be different types of circuit breakers depending on the current rating, right? Circuit breaker, as the name suggests, it breaks the circuit, right? So whenever there is fault that is detected by the relay can give command to the circuit breaker, and the circuit breaker will basically just break the circuit so that there is no high current passing through the circuits, damaging any equipments that the panel might be connected to, right? The most common circuit breakers that you might be dealing with in your everyday life are MCBs, miniature circuit breakers, right? Those are also types of circuit breakers, but they have very low rating, right? So that is usually used for domestic wiring, right? So there can be different types of circuit breakers as well. We'll talk about that as well. Then there can be relays, right? Relays, like we discussed, relays basically detect any fault condition, any short circuit condition that might have led to high current passing through the electrical panel. And basically the electronic relay or the electromechanical relay passes a signal to the circuit breaker, and the circuit breaker trips open, it breaks the circuit, it saves the system, right? So there can be different types of relays as well. They have their own hazards. We'll talk about that as well. Then there can be capacitor banks. Basically, capacitor banks, you can think of them as batteries, right? In case of emergency processes, they basically store uh, the electricity and also help in increasing the power factor, right? The power factor can range from 0 to 1. If the power factor is closer to 1, basically that's less electricity bill, right? So a lot of industries use capacitor bank panels, right? So if there are capacitor bank panels, sometimes if there is testing and maintenance going on an electrical panel, if the capacitor banks are not disconnected, there can be additional supply coming from the capacitor bank that you might not be aware of, and that might also lead to an arc flash or an arc blast. Then there can be diesel generators for emergency situations. In case there is an electricity cutout, there can be diesel generators that might run as suggested in on diesels, and it can generate power. It can provide electricity for a short amount of time. So the diesel generators, it's an electrical system as well as it can be considered as a mechanical system, because this also has a diesel engine. So they have their own hazards, and we'll talk about those as well. So the power distribution transformers, right? You must have all seen these kind of transformers that might be there in your substations. A distribution transformer or service transformer is a transformer that provides the final voltage transformation in the electrical power distribution system. Right? There can be two types of transformers, a step-up transformer or a step-down transformer. Step-up transformer basically increasing the voltage, and step-down transformer reducing the voltage, right? Mainly in all industries, we have a step-down transformer that reduces the voltage from 11 kV to maybe 440 volts or 450 volts. All right, so that voltage rating can be used in for industrial supplies. Uh, Stepping down the voltage used in the distribution lines to the level used by the workplace. Distribution transformers are normally located at a service drop, right? Wherever your local electricity service, like for Qatar, you can say Karama, right, is supplying the electricity. Wherever there is a service drop, you can locate a transformer, a step down transformer to be particular, that might be stepping down the voltage for your industrial use, right? Where wires run from a utility pole or underground power lines to a workplace premises. Has two windings, right? Any transformer has two windings, has a primary winding and a secondary winding. For a step down transformer, the primary winding might be more in size than the secondary winding, right? Depending on the ratio, depending on the voltage rating. The secondary winding can be adjusted. There are taps in the transformer, so depending on your requirements, you can adjust the secondary winding to the voltage level that you want to use in your industry, in your workplace. The cables of secondary connection connected to the bus bars in the incomer panel in the electrical room, right? There might be cables running from the distribution transformer to the incomer panel in your electrical room, right? Supplying direct electricity to your electrical room. Then there can be high voltage cables, right? High voltage cables, thick cables that have again very low resistance, so it can supply high amounts of current. A high voltage cable is a cable used for electric power transmission at high voltage. High voltage cables of different types have a variety of applications in instruments, ignition systems, and AC and DC power transmission, right? Usually it is AC power transmission. Whichever industrial transmission is happening, that is AC transmission. Modern HV cables have a simple design consisting of a few parts, right? They have different types of insulations. Since it is a high voltage cable, since there is high current passing through it, they need to have various layers of insulation, right? They have a few parts like the conductor shield, the insulation shield, the metallic shield, and the overall jacket. Usually when we talk about the normal domestic wiring or the electrical wiring that we usually deal with, they have double insulated cables, right? They have the core, the conductor. There are, if it's a three-phase supply, there are four cables inside, right? For three phases and a neutral. So there are three cables. Individually they are insulated, and there is an overall insulation as well. But for a high voltage cable, it is much more hazardous. So it needs to have the additional insulation shields, the metallic shield, and the jacket as well. Then there can be current transformers and potential transformers. Now current transformers can be at two different locations. One can be outside near your power transformer. That will be on the supply side from Karama, right? The top photo that you see over here is outside in the substations. Those are the current transformers, three transformers for three phases, red, yellow, and blue, uh, right? And the bottom one that you see, in bottom also you can see six in total red structures. The three on the top are the current transformers, and the three on the bottom are potential transformers. The current transformer is connected directly to the bus bar, right? The primary side connected to the bus bar, and the secondary connected to the relays. A current transformer is a type of transformer that is used to reduce or multiply an alternating current, right? They have two secondary cores. One is for metering, one is for measuring the current, and the second is for protection, for giving the command to the relay in case there is a fault. It produces a current in its secondary which is proportional to the current in its primary, right? Current transformers along with voltage or potential transformers are instrument transformers, right? Instrument transformers scale the large value of voltage or current to small standardized values that are easy to handle for measuring instruments and protective relays. Voltage transformers are designed to present a negligible load to the supply being measured and have an accurate voltage ratio and phase relationship to enable accurate secondary connected metering, right? All of the current transformers and potential transformers need to be inspected. They need to be tested as well. The ratio has to be checked if it is transforming the current or the voltage as per the ratio specified on it. All right. Then there can be circuit breakers. Like we discussed, there can be different types of circuit breakers based on the current rating of the system. Here in the photo that you see, the first, the top left of the circuit breaker that is mentioned is the SF6 circuit breaker, usually on a power transformer that is outside, all right, in your substation. Next to it is the air circuit breaker, usually located on your electrical panels in the electrical room. Next to it is the MCCB, or also known as molded case circuit breaker, right? Next to it is the MCB, right? Mainly on the electrical panels, right? In the bottom, the left side, the first two are the VCBs or vacuum circuit breakers, and the rest are the SF6 circuit breakers. All right, a circuit breaker is an electrical safety device designed to protect an electrical circuit from damage caused by an overcurrent or short circuit. Right, there can be short circuit happening because of different things, different environmental factors, or different fault conditions. And because of that short circuit, there can be high current that might be generated, which might damage any equipment that might be connected to the electrical panel. So in that case, it is always better to have a circuit breaker in place. You all basically know how MCBs work. If there is high current that is passing through the MCB is going to trip. It is going to break the circuit, and you need to identify the fault. You need to rectify the fault, and you can switch on the MCB again, right? In a way, if you want to talk about it, fuse is also one sort of an MCB, right? But when it comes to fuse, if the fuse is stripped open, you need to replace the fuse. Whereas if you have a circuit breaker, you can just rectify the fault and switch on the circuit breaker back again. Circuit breakers are made in varying sizes, from small devices, that is the MCB, the miniature circuit breaker, to protect low current circuits or individual household appliances, to large switchgear designed to protect high voltage circuits feeding an entire city. Right, that might be the SF6 circuit breakers, or vacuum circuit breakers, or air circuit breakers. Types of circuit breakers, like we discussed, they can be miniature circuit breaker, that's the MCB that we use almost every day. There can be molded case circuit breakers, that is the MCCB. There can be earth leakage circuit breaker, that is the ELCB. Right? There is a separate circuit breaker for earth leakage. In case there is high current flowing through the earth, that is also very hazardous. So there should be a circuit breaker connected to the earthing as well, or to the grounding as well. So there can be an earth leakage circuit breaker, air circuit breaker in your electrical panels, vacuum circuit breakers, and also SF6 circuit breakers. Particularly with SF6 circuit breakers, when they are connected to the transformer, in case you want to break the circuit manually, there can be high chances of arcs getting developed between the contacts of a circuit breaker. SF6 circuit breaker is out in the open, so whenever breaking a circuit, no one should be around that circuit breaker. When it comes to ACB or VCB, also there can be high chances of arcs getting developed. But for ACB and VCB, we have air in between, or vacuum in between, to contain the arc from spreading and starting an arc flash or an arc blast or a fire or an explosion. Right. So then we have air circuit breaker, that is the ACB, vacuum circuit breaker, and SF6 circuit breaker. Relays, mostly we have now transitioned to electronic relays, right? Developed by different companies. It might be Siemens relays, Schneider relays, ABB relays. There are different companies that provide different types of electronic relays. And since they are electronic relays, they can't withstand a high amount of current or voltage. So that's where the current transformers come into place to step down the current. The relay, a protective relay, is a relay device designed to trip a circuit breaker when a fault is detected. Different relays have different functions. They can detect different types of faults. Usually, a standard relay can be used to detect any overcurrent fault, if there is an overcurrent happening in the circuit, or an earth current, if there is too much overcurrent happening in the earth circuit. That can be detected by the relay, and it will automatically give a tripping command to the circuit breaker for the circuit breaker to trip open. The first protective relays were electromagnetic devices. The ones on the bottom are the electromagnetic devices. They work on the electromagnetic functions. They are more of a, you can say, mechanical relays, right? But those also have their own disadvantages. They have different contacts, they have different small parts that if they do not work properly, it can lead to a big disaster. So now they have been changed in most places to electronic relays, relying on coils operating on moving parts to provide detection of abnormal operating conditions such as overcurrent, over voltage, reverse power flow, over frequency, and under frequency. Right? Usually the power that we get in the supply is 50 hertz frequency. If there is over frequency or under frequency, that can also be detected by the relays and it can immediately give a tripping command. Now they are replaced by microprocessor based numerical relays or electronic relays. Various standards are there for the relays as well. It can be ANSI standards, IEC standards, and IAC standards. They govern the response time of the relay to the fault conditions that may occur. Depending on the fault condition, depending on the rating of the current, higher the rating, bigger the disaster. So depending on the rating, depending on your requirement, system requirement, it can be customized. The electronic relays can be programmed as such to detect the fault and trip in the minimum amount of time, basically in mere milliseconds. It can give a tripping command to the circuit breaker. Then there can be capacitor banks, basically a panel with huge cells, you can say. A capacitor bank is a physical group of several capacitors that are of the common specifications, are connected in series or parallel with each other to form a capacitor bank that can store electrical energy. The capacitor bank so formed is then used to correct a power factor lag or phase shift in an AC power supply, right? To rectify power factor, to keep the power factor close to 1, right? So that it helps in the electrical supply. Capacitor banks can also store energy in case there is a power cutout. Electricity can be obtained from the capacitor banks. They're basically batteries. Capacitors are batteries, so they can be charged. And in case there is in case there is a power cutout or an electricity cutout, there can be electricity supplied from the capacitor banks. Uh, then there can be diesel generators. Pretty sure everyone has seen diesel generators, or a DG, also known as a diesel genset, is the combination of a diesel engine with an electrical generator, right? So it's basically there is a combustion of diesel that is happening, and the electrical generator that can generate the electrical supply in case there is a power cutout. Diesel generating sets are used in places without connection to a power grid or as emergency power supply if the grid fails, as well as for more complex applications such as peak lopping, grid support, and export to the power grid. Diesel generators, the main advantages, they are kind of, you can say, portable. So in case there is a construction site and there is no electrical supply, you can always rely on diesel generators to provide you electrical supply for the meantime while the electrical connections are getting sorted out. So diesel generators, since they are electrical and mechanical, they have electrical hazards as well as mechanical hazards. Since they are running on fuel, they are running on diesel or gasoline, right? They have that the diesel, the gasoline, the handling of diesel or gasoline has their own has its own hazards, and the electrical generator also has its own hazards. So now that we have covered some basic electrical installations that you can find in your workplace, let's move on to the hazards whenever working around high voltage. There can be different types of hazards, various hazards when a work is conducted around high voltage. Most people do not realize that the overhead power lines are uninsulated, right? Like we discussed, any overhead power lines that are passing through are uninsulated, and hence there is a high risk of electrical arcing, right? Just to tell you, just today morning, while I was going to work, I saw an electrical line, an overhead power line on fire, and there was a guy from the ground just trying his best to extinguish any kind of arcing that might have still remained. I don't know where the electrical cutout happened, but yes, there can be these kind of huge electrical arcs that might be produced and can lead to huge disasters. Most people do not realize that the overhead power lines are insulated, and hence there is a high risk of electrical arcing. The arc can jump to several feet depending on the voltage and can cause arc flash or arc blast. Arc flash is basically the development of sparks or arcs. You all must have seen arc welding, that is the electrical version of welding, where you are basically generating an arc, but that arc is in your control. You can control the voltage rating or the current rating in the arc welding, and the arc is in your control. If it gets out of control, it can be a huge disaster. It can burn people's clothes or the skin. People might need to be hospitalized immediately. Short circuit of high magnitude of current can cause arc flash, and if there is a pressure wave developed along with it, it can be termed as an arc blast. It is literally an explosion. People can go flying, right? Like we see in movies, those kind of explosions, those kind of arc blasts can happen. If the underground cables are struck during excavation work, that can also lead to arc flash, shock, electrocution, burns, and fire. Right? There can be arc flashes that might be happening in case the shovel in the excavation or the excavator hits the underground power lines. There can be shock that might happen. That shock, that is the minor shock, or there can be electrocution, that is death because of electric shock. The person's heart might stop beating. He might die as a result of it. There can be burns, electrical burns, and can also lead to fire or explosion hazards. Right, that's the photo for the arc flash that might happen. All right, identifying the hazards. There are high chances of arc flashes whenever a circuit breaker trips open. Basically, a circuit breaker is a switch. It has a fixed contact and a moving contact. So whenever the circuit breaker receives a tripping command, the moving contact moves, it breaks the connection, and the circuit is broken. But when the moving contact moves, there is an arc that is developed between the two contacts for a fraction of a second. If that arc is not contained, there are high chances of arc flashes happening around circuit breakers. When moving contact breaks the circuit, there is an arc formed between the two contacts for a moment. To contain that arc, different circuit breakers have different materials, different elements such as air or vacuum. Since there is a vacuum, since there is no medium for the arc to spread, the arc will be contained. Or there might also be SF6 for the transformer circuit breakers to prevent that arc from spreading. The mechanism depends upon the current rating of the circuit breaker and the type of circuit breaker. If the arc is not contained, it can lead to big disaster. Right? There can be huge accidents that can happen around these kind of high voltage, high current circuit breakers. Electrical arcing or arc blast can also be caused if the secondary winding of a current transformer is either open or the connection is loose. If the secondary winding is open because of the current being open, because of the circuit being open, there can be high voltage that might be generated on the secondary winding of the current transformer, and that can cause another case of electrical arcing or electrical shock to any service personnel. So whenever there are current transformers involved, make sure that all the secondary circuits, the secondary connections are connected, and also they are tightened to the best of the person's capabilities, right? Even if there is a minor loose connection, it can lead to a huge disaster. It can straight away lead to an arc blast. Current transformers are step-down transformers. If the polarities are inverted by any chance, it can also lead to an arc blast, right? In case the polarities are not mentioned, in case the primary windings and secondary windings are not marked, in case the polarities are reversed while the current transformer is being connected, uh, there can be high current produced on the primary side, and that can also lead to an arc blast. Because of small arcs produced between contacts of an electromechanical relay, right? If there are electromechanical relay, it can detect the current, and basically it has metal contacts which are basically giving a signal to the circuit breaker to trip it open. If those contacts are not cleaned because of those sparks, because of those minor arcs that might be developed, there might be carbon accumulated on the contacts. If that carbon is not cleaned up, if those relays are not maintained regularly, it might also affect the tripping time of the relay, and it might also lead to a huge disaster. It can lead to high current passing through the circuit and might also damage all of the equipments connected to that circuit. That's why it's always better to move on to transition to an electronic relay or a numerical relay. All right. can think of the capacitor banks as batteries. Capacitor banks are basically batteries. With the capacitor banks, there is also harmonics that are produced. So those harmonics also need to be uh, they need to be kept in check. They need to be tested. They need to be inspected regularly. With capacitor banks testing, with the harmonics testing, what happens is the inspector needs to check the harmonics on live system, right? You cannot really isolate the capacitor bank to check the harmonics. It should be a live system. So that has its own hazards. All right. In absence of proper ventilation around capacitor banks, capacitors can also overheat, just like batteries do, and can lead to failure of the capacitor banks as well. The harmonic distortion in the capacitor banks need to be tested when the system is live, and live system possesses its own major hazards, right? Uh, Whoever are working in the safety department, you all know that there are different types of permits for an electrical system. One is for the electrical system that has been isolated, and another permit is for the electrical system that is live, right? There are way more control measures that are required to work on a live electrical system. Any person carrying out the testing and harmonic distortion should always wear level 4 arc flash PPE. All right, because there is always a high amount of electricity flowing through capacitor banks, and they need for checking the harmonic distortion. There are different testing devices. They need to basically put the person carrying out the testing needs to put their hands in the area of danger, and if by chance he touches the electrical cable, there might be a major case of electrocution. So they should always have a level 4 arc flash PP on them. Then let's move on to the safety precautions for electrical installations in the workplace. Right, for power distribution transformers, the electrical transformer needs to be checked prior to installation for any burning smell, faulty parts, or abnormalities in continuity. Any maintenance work must only be undertaken after the equipment is de-energized and tagged out and the circuit is shut down, right? This is necessary to ensure that there is no leakage of current or continuity between the hose current and the system. Transformer grounding should be in place at all times. Whenever there is testing and maintenance happening of an electrical system, the transformer needs to be shut down, it needs to be locked out, it needs to be tagged out, and the isolation needs to be verified. When I was working back in electrical field, there was this one case where we went to a site for testing and maintenance of electrical systems. And what happened was we isolated the transformer. We checked the electrical drawing to check where the connection was coming from. We isolated the transformer to isolate all the electrical systems. Once the electrical systems are isolated, there is still stored energy, there is still stored electricity in the bus bars of the electrical panel. So all of that stored energy, all of that stored electricity needs to be put into grounding, right, to truly isolate an electrical panel. And so what happened was we usually use electrical rods, earthing rods, to put that electricity into the earthing system. And one of my colleagues, he opened the panel from the back and he went to put the earthing rod to the bus bar to earth any kind of stored electricity that the panel might have. As soon as he touched the earthing rod to the bus bar, there was a short circuit that happened. There was an arc flash that happened. Luckily, my colleague had survived. There was no major injuries for him, but there was the substation supervisor who was talking to him. He was not really paying attention to the work that was going on. The arc flash happened behind his back, and he was standing several feet from the electrical panel, and it still burnt his clothes, it burnt his skin, his entire skin from the back up until the top of his head, and he was hospitalized immediately. That mainly happened because that electrical panel was also connected to a capacitor bank, which had stored energy, and there was supply coming from the capacitor bank. So when my colleague went for earthing, that high current flew through earth, and the earthing rod didn't have capacity, and that led to an arc that happened, an arc flash that happened. And so those kind of disasters can happen. So that's why it's always important that whenever there is isolation happening, that isolation needs to be verified before any further steps are taken, right? You need to check the meters, you need to check the relays if there is no voltage inside the system. All right. The transformer must be inspected periodically to ensure that no foreign nuts, bolts, or spare parts have fallen into it. Right? If there was maintenance going on, there might be tools that might have fallen into it. There might be other things, foreign materials that might have fallen into it. The electrical transformer and all of its components must be free from moisture at all times, as any contact with water can prove to be hazardous. You all know electricity and water don't go hand in hand. So there should be no water, there should be no moisture around any electrical systems. If any irregularity or abnormality is observed in the functioning of electrical transformer, it must be shut off and all the cables and power cords must be unplugged before analyzing which part of the transformer is malfunctioning. For a power distribution transformers, there are various types of tests that are carried out, such as ratio tests. There are magnetic imbalance tests, leakage current tests, leakage voltage tests. All of those tests have to be done regularly. Usually they are done annually, every yearly, right? Just to check the functionality, the efficiency of the power distribution transformer. Then the high voltage cables. For high voltage cables, they should be installed according to British standards and the standards specified by Institute of Electrical Engineering. Regular testing and inspections need to be carried out for the high voltage cables as well. It should have an IR test. It should have an insulation resistance test. Usually we use Megger kits for insulation resistance test, and that has to be done. Core continuity and identification, and also conductor resistance test. Right, the conductor that's present inside the high voltage cable, the resistance of the conductor also needs to be checked. uh, Use insulated tools, wear flame resistant clothing, safety glasses, and insulation gloves. Always have your PPE in case there is an accident happening. Accident can happen anytime, anywhere, so it's always better to have your PPE. Remove watches or other jewelry, stand on an insulation mat while cable testing is being carried out. Use proper lockout tagout procedures. If these procedures are not in place or not enforced, assume the circuit is live. For current transformers and potential transformers, when removing the instrument or relay during use, the secondary side shall be short circuited in advance. During installation, the wiring shall be reliable and it is not allowed to install fuse at the secondary side of the current transformer or the potential transformer. The polarity of the current transformer should be taken care of. They should be marked clearly, not to be confused with for the primary winding to the secondary winding. The primary and secondary sides of the current transformer should be marked clearly. The primary and secondary connections should be tightened properly. Any loose connections can also lead to major fatal accidents or arc blasts. The fuses attached to the potential transformers need to be tested and maintained regularly as well. For the potential transformers or voltage transformers, there are fuses, big size fuses connected on the top of the potential transformer. So when there is regular maintenance going on for an electrical panel, those fuses of the potential transformer also need to be cleaned for any carbon that might be there on the fuse before installing them back. For circuit breakers, always wear appropriate arc flash PP when working with electrical room circuit breakers. Whenever you want to manually trip open a circuit breaker, always have your arc flash PP. Always trip the circuit breaker with your right hand when your body should be out of the way of the electrical circuit breaker. Whenever the circuit breaker is operated, there is an arc formed between the two contacts. Different circuit breakers have different mechanisms, but if in case that mechanism fails, it can lead to a big disaster. If installing a circuit breaker, always check its specifications, always check its current rating, check if the ampere rating satisfies your requirements. If the circuit breaker has been installed already or repaired, there should be a thorough inspection done before putting it in service condition. For a circuit breaker as well, whenever there is regular testing that is happening, regular maintenance that is happening, the tripping time of the circuit breaker should also be checked. right? Circuit breakers should be inspected regularly, which should also include testing their tripping time. For relays, relays should be according to the British standards BSEN 60255. Relays are programmed to give a tripping command to the circuit breakers under various fault conditions. You need to check the electrical drawing. You need to check what are the different types of fault conditions that might happen in an electrical system, and you also need to be checked or what are the different types of faults that the relay might be programmed for, and all of those fault conditions need to be tested for regular testing and maintenance. All of those conditions should be checked during regular inspections through secondary current injection, right? There can be secondary current that might be injected to the relay, and you can check the tripping time in each condition. All the electromechanical relays should also be cleaned and tested regularly, as a small amount of carbon on the contacts can lead to change in tripping time drastically and can consequently turn into an accident. For capacitor banks, capacitors shall comply with BS 1650 and must have low losses. Each capacitor should be in different housing equipped with a disconnect device. They should have a disconnect device like we discussed about the incident that happened before. If there are capacitor banks, they also need to be disconnected. They should have a disconnect device. They need to be disconnected from the entire electrical system before that electrical system is grounded, earthed, tested, or maintained. The harmonics of the electrical panels connected to capacitor banks should be monitored regularly. The capacitor bank should also be protected with fuse switch or circuit breaker, which will trip open in case a fault occurs. If leaked liquid from capacitor gets into ice, capacitors basically run on chemicals. In case there is a chemical leakage and it gets into your ice, there is a different first aid procedure for cleaning chemical from your ice. Wash your eyes thoroughly and clear out the chemical. Also be careful that the chemical in your eye does not run from one eye to the other. If you smell leakage, keep yourself safe and keep away in case there is a chance of fire or an explosion. For diesel generators should never be placed in an enclosed spaces. Like we discussed, they have a diesel engine which will be producing fumes, which will be producing basically carbon monoxide. So if it's in an enclosed space, if it's in a closed confined space, there can be too much carbon monoxide. The people working around might suffocate as a result of it. It should be always in an open space or a well ventilated space to let the exhaust fumes out. Keep any water sources away from the diesel generator. In case the diesel generator is being refueled, it is to be ensured that the generator is cooled down before you refuel it. If it is not cooled down and you refuel the diesel into the generator, it might also lead to an explosion because of the heat and the fuel. If there are power cables leading to the generator, they can act as tripping hazards as well. So be careful about any kind of power cables around the generator. It might cause a slip, trip, and fall hazard as well. Lastly, the emergency procedures in case there is an accident. Whenever an electrical accident happens, the people should safeguard themselves first before attempting a rescue. You know about all the emergency procedures. Wherever there is emergency, you need to ensure your safety first before you try to rescue someone else, right? If you are also involved in an accident while you are trying to rescue someone else, that's of no use to anybody. So keep yourselves safe first, safeguard yourselves first, and then you can attempt a rescue on anyone else. The first step should always be to stop the current or break the circuit with appropriate safety measures. Always have your PPE ready, and you can manually trip the circuit breaker to break the circuit. Always stand on non-conductive mats when trying to rescue a casualty, right? There are different types of non-conductive mats that might be available. Always use those. They're basically usually there on electrical rooms, so that there is proper insulation and there are less chances of any electrical shock that might be happening. Check if the person is breathing, if the person was involved in electrical shock, if he's disconnected from the circuit. Check if the person is breathing. If not, CPR needs to be carried out. CPR, like you know, that's cardiopulmonary resuscitation. That's basically chest compressions and mouth-to-mouth breathing. That needs to be carried out while you wait for emergency services. If there is an AD machine available, you can use the AD as well to attempt defibrillation to restart the person's heart, right, to revive the casualty's heart as well. All right, so that basically brings the topics to end. That basically brings the webinar to an end. Now it's up to you guys. It's open for any kind of questions, any kind of doubts that you might have for the topic.
Thank you, Valmik. So if you have any questions, everyone, you can just write it on the chat function, which is just on the right hand side of your screen, and I will read it out to Valmik. We'll just wait just a few more seconds if there's any questions, and I will let you know, Valmik.
Okay, all right.
Okay, so I don't think there's any questions from our side, but thank you so much for the very informative presentation, Valmik. We do appreciate you taking your time out to present this. Deepu, do you have any further comments or anything you might add?
Yeah. Thank you, Valmik. Thanks for the nice presentation. It was quite interesting one. And I believe the members who have attended the section, guest, has enjoyed the session as well. So
Yeah.
no more questions. So we will be winding up our sections for today. So see you all again for the next month meeting, August. I believe in August month also we will be going through online section from September onwards. So August at the end, summer holidays will be over. So from September onwards, we will try to start the face-to-face section as well. Let me try along with the face-to-face. We will try for online also, like which we tried on last year or November, December month, which we have tried. Same way we will try again this time. So thank you all. Be safe. Thanks for attending the session. And thank you, Susan. Thanks for arranging the session. And thank you, Valmik.
Thank you. Thank you very much. Thank you very much for attending the session.
All. Thanks. Bye.
So bye-bye.
Bye, everyone.